This is the video presentation of individual paper presentation of software engineering. I'm giving a presentation on a lightweight methodology for rapid ontology engineering. This is a paper by Antonio de NICOLA and MICHELE. So let's discuss about what an ontology means. An ontology is a conceptual model of fragment of an observed reality. It is in essence a repository of interlinked concepts pertaining to a given application domain construction of an ontology, and its constant evolution is very necessary and keep it aligned with reality. It's lengthy and costly. Ontology engineering help domain experts better understand their own business reality by systematically exploring and describing it. Ontology engineering is difficult for non-ontological specialists like business experts, but UPO and upon light help them understand and develop the ontologies without ontology engineers until the final step of formalization. The main objective of this is to shift responsibility for ontology building toward a community of end users through a social, highly participative approach which is supported by an easy to use methods and tool. I just talked about OPEN, and it stands for Unified Process for Ontology Building, which is a methodology that we use which guarantee us a rigorous, systematic and also an intuitive nature. Upon Light is organized as an ordered set of steps. It has 6 steps, each releasing a self-contained artifacts readily available to end users. So let's discuss about Upon Light. Upon Light has 3 main pillars of ontology developments. One is user-centered approach, that's emphasizing the role of domain expert. Other is social approach, leveraging the collective intelligence of domain experts, working to progressively achieve the steps in the methods. And ontology itself, that's articulated in 6 steps, each producing a readily usable outputs. So in the sequence here shown, we have 6 Upon Light steps that are lexicon, glossary, predication, taxonomy, parthood and ontology. So discuss about domain terminology. In this paper, the domain terminology stands for the lexicon, which lists the domain terms which characterize the observed domain. Second part is the domain glossary, that term of lexicon which is associated with a textual description indicating also possible synonyms. The third is taxonomy, domain terms organized in a general specialized hierarchy. The fourth is predication, which represents properties from the glossary identified and connected to the entities they characterize. Parenthood, complex entity named connected to their components with all the naming need to be present in the glossary. And sixth but last not the least is ontology, which is the last step that produces the formally encoded ontology by using, say, the web ontology language, which is OWL, and contain conceptual knowledge and collected in the previous steps. So the social approach to rapid ontology engineering, users need to proceed along 3 lines. 1. Adopt simple tools. Number 2. Open boundaries. And number 3 is reiterating the process. So let's discuss about terminological label. The first step is Upon Light, involving creating a domain specific terminology or a list of terms characterizing the domain at hand. The outcome of this step is a domain lexicon or information structure used to answer the question like what are characterizing the word, noun, verbs and adjective typically used while doing the business in the domain. This is primarily steps to start identifying domain knowledge and drawing the boundaries of observed domain. A number of natural language processing tools are available for extracting terminology from the text. So this can be said like this, and it has certain challenges. The challenge in deciding a term is relevant and thus to identify the boundary at the target. application domain to include in the lexicon only the appropriate terminology. Social validation is another key language where users have no problem in publishing a particular lexicon online. So the second step is glossary. So it is critical, and in fact there are terms in here where a well-defined and widely accepted meaning, even defined by the regulations and laws such as those that apply to invoices, but they are also widely used terms that may have a different meaning in different situations. So it has challenges, and let's talk about the challenges. Users here often find contradiction or description pertaining to different points of view or different roles in the enterprise, as when, say, an accounting department describes inventory differently from a stock management department. So it may create a problem in there. That's a glossary level problem. In case of a multiple description, user can create a synthesis or according to the objective and scope of the ontology privilege one over the other. So the third is we talk about taxonomy level. The first is taxonomy based on a specialization relation or ISA relationship, which connect a more specific concept to a more general one. Here, a taxonomy represents the backbone of an ontology, and its construction can be challenging. So, as we just talked about the taxonomy, there are challenges as well. It's difficult in organizing a flat list of concept names or glossary terms into a taxonomy. We must be careful while considering different perspectives and opinions. The basic mechanism consists of clustering of concepts or terms, linking them to a more general concepts, and the bottom-up approach. The fourth step is predication level. This is the step which is similar to database design activity, as it concentrates on the properties that in the domain at hand characterize the relevant entities. So there we have two properties, that is, one is atomic property that can be seen as printable data fields or a unit price, and a complex property that exhibit an internal structure and have components that, like address, it has street, postal code, state, country, phone number, etc. So let's talk about the challenges in predication level. The challenge is, for example, when we talk about an address, which can be a complex property as covered earlier in this article, or can be an atomic property where the whole address is encoded as one string. Likewise, an RP can be substituted by an AP, that is an atomic property, if user adopts a relational database approach. So this is the challenge. So the fifth step is the parthood level. The architectural structure of the whole business entities are the part of composite entities, object, process, or actor by eliciting their decomposition hierarchy. Here, end user would analyze the structure and the component an entity exhibits, creating the hierarchy based on part of relationship. Parthood can also be applied to intermaterial entities, such as a regulation subdivided into sections and articles, or a process which is subdivided into sub-processes and activities. In sub-processes and activities, user can enrich the model with other relations, such as precedence, string, a subject beyond the scope that is of this article. So we have the challenge here, and when we consider a price and then the unit price, it is not evident if the unit price is a special case of the former or part of it. So such relationship is highly dependent on business and organizational choices. Also in general here, the user's context determines the relationship, and eventually social validation that provides final interpretation, with a central role for the ontology masters. The sixth level is ontology, where here it gathers all the knowledge collected in those steps, in particular the concept in step 2 and the semantic relationship elicited in steps, that is a taxonomy which is in step 3, which is further increased by the step 4 which is a predication, and the parthood which is a step 5. Here It is also possible to formally represent constraints such as typing and cardinality constraint and the needed domain-specific relationships. This is the chart. The challenge here is that it concerns the choice of how expressive the ontology engineers want the ontology to be. A minimum option is to include the taxonomy and the reference property in the form of domain-specific relations. The second challenge concerned encoding the ontology in formal terms. Here, the role of ontology engineer is central because there is a high level of expertise required at this stage. Okay, so what are the ontology engineering key features? Number one is social and collaborative aspect of ontology. Number two is supporting tools. Number three, domain expert. 4, cost efficiency. 5, adaptability. 6, reusability. 7, stepwise and cyclic approach. 8, natural language documentation, and last but not the least is organizational structures. So in conclusion, what we know now, upon light and ontology engineering methodology is based on a lean incremental process which is conceived to enhance the role of end user and a domain expert without specific ontology engineer expertise. It's a derivation of a full-fledged open methodology. Upon light is characterized by the three aspects of ontology engineering. Like I just told you earlier, it's in user-centered approach, socially oriented approach, and intuitive ontology approach. So that's all. Thank you.